How do you quantify the acceptable level of risk when management and engineering have different definitions? Quantifying the acceptable level of risk requires bridging the gaps between engineering data-driven analysis and management financial and strategic perspectives. And this is achieved by utilizing quantitative methods that translate risk into consistent, measurable metrics, often monetary, all guided by established industry standards and legal principles like OSHA, EPI, API, and 𝗲𝗂𝗴𝗴 principle. Here is a breakdown of how to approach this. 1. Establish a common language through risk quantification. Engineering and management often have different ways to describing risk. Engineers typically focus on technical metrics like a probability of failure of component or system, consequence modeling, and safety integrity level SIL. On the other hand, management focuses on return on investment, balance sheets, regulatory compliance costs, and public image and brand reputation. The key is to translate engineering metrics into terms management understands. How? By using quantitative risk analysis to convert likelihood and severity of an incident into common monetary value or the value of statistical life, VSR. And this makes potential losses tangible. 2. Adhere to a formal risk management frameworks. Start with a formal risk assessment matrix, for example 5x5 matrix, that explicitly defines the boundaries for broadly acceptable alarm and unacceptable risk based on a combination of likelihood and severity, and core definitions to recognize industry standards and regulatory thresholds. OSHA and EPI regulations provide a minimum legal compliance requirement. IPI recommended practice 754 define process safety events by severity tiers, tier 1, tier 2, etc. And IEC 61511 provides guidance on the required safety integrity level for safety instrumented system. 3. Apply the 𝗲𝗂𝗴𝗴 principle. Risk in 𝗲𝗂𝗴𝗴 region are tolerable only if the cost of further risk reduction measures is disproportionately high compared to the safety benefit gain. Now, the reasonably practicable aspect is where management and engineering debate costs. Engineers must present a business case, return on investment analysis, that clearly outlines the cost of mitigations versus the reduction achieved. This requires a detailed analysis to show that the cost to mitigate risk is less than the value gained by applying this mitigation. And finally, ensure stakeholders' alignment and transparency. The process must involve all stakeholders, from the site floor personnel to the corporate management, to ensure buy-in and shared understanding of risk. Involve management and engineers in the development of the risk tolerance criteria from the outset and not just at the final decision point. By using these methods, company can move from subjective disagreement to an objective data-informed decisions. Thank you for watching. See you in the next video.